The next question is 0.1 molar solution of 3 sodium salts NaX, NaY, NaZ have pH values 7, 9 and 10 respectively. Increasing order of acidic strength of 3 acids HX, HY and HZ. Here the salts given are NaX, NaY, NaZ, and these being salts, it is indirectly NaOH strong base and an acid HX. So one acid is HX. Likewise, this is NaOH HY, salt of strong base NaOH and then HY. We need to check whether HY is strong acid or not. NaZ is the salt of NaOH plus HZ. Now the pH values given respectively for the three salts for same concentration of 0.1 molar. Concentration is same. But the pH of the aqueous solution of the first one is 7 given, second one is given 9 and the third one is given 10. pH is increasing, and if you observe this particular case, it is 7. In other words, the solution is neutral. In other words, the H plus is equal to OH minus. That is, NaOH concentration is equal to the concentration of HX. Therefore, it must be a strong acid since NaOH is a strong base as it is getting neutralized. So that the solution will have pH 7. So HX is a strong acid. But when you see NaY, its aqueous solution is having a pH of 9. In other words, it is more basic than the previous salt NaX. That is, the solution is having more of OH minus concentration, which will be possible when HY is relatively weaker acid comparing to NaOH. Therefore, so if HY strength is less than that of HX, then only the total NaOH will not be neutralized. Some amount of OH minus will be left over, and that becomes responsible for the pH to be 9, which is more than 7 by 2 units. So here the strength of HY is less than HX, so that this HY is not able to neutralize totally the NaOH. Some amount of OH minus is left over. Therefore, the solution is having more of pH concentration than 7. Similarly, if you observe the last case, NaOH and HZ, the pH is much more. That is, it's 10. In other words, more of OH minus is left in the solution even after HZ being added. That is, HZ is not able to neutralize the NaOH even to the extent of what HY is doing in the previous case. So since the pH is 10, solution is more basic, more NaOH is left over unneutralized, which is possible if HZ is still less acidic than HY and HX. From this we can understand that the strength of HX is more, thereby it is able to neutralize totally NaOH, giving the pH 7, and HY is having less strength, not able to neutralize the NaOH totally, and the OH minus concentration is more and the pH of the solution of the salt is more. Further, the last solution is having pH 10, indicating that more of OH minus is left over in the solution. NaOH is neutralized to much lesser extent than in the second case. So HY strength should be more than HZ. In other words, HX is stronger acid than HY than HZ. Now taking this into account, let us select the correct answer from the given answers. We find A as HX is equal to HY is equal to HZ. This indicates that all the three are equal in strength. If all the three acids HX, HY, HZ are equal in strength, then all the three solutions of the salts could have been same pH value of 7. So therefore A is definitely wrong. And then B is given as HZ less than HY less than HX. In other words, nothing but HX is more than HY is more than HZ. Therefore, this option B is right. So the other options, naturally when you observe, HX is less than HY is less than HZ. It should be the other way around. Therefore, C is wrong. Then D option is given as HY is less than HX and less than HZ. So it is showing that HY is least acidic. If that could have been the case, NaY could have had less pH. In the D option, HY is less than HX, less than HJ. So HY is least acidic. Then NaY could have had more pH value even than HX. So therefore it is wrong. So the option is B. So A is wrong, B is right, C is wrong, D is wrong,